Okay, so I'm sharing the screen right now. Here's my data flow diagram here. Basically, the core of it over here is generally the same as what Edwin had taught us, except that I changed the data source to a Raspberry Pi, and it's actually taken real sensor data from a couple of different sensors: proximity sensor, accelerometer, gyroscope, and GPS. Although today I'll just be focusing on the proximity sensor because I can actually do a good demo with that very easily. With the other ones, it's a little bit harder, especially with GPS, since I'm not even moving. And as usual, as the standard skeleton goes, it feeds data to NIFI, which then puts it into SQL, and Kafka Connects provides it to Kafka, and then we've got Spark streaming, consuming that data, and then outputting that into Hudi data. I've also added a little Kafka consumer here, just as a Python script, which we'll see later, just to help us monitor the data. And then over here, there's some very basic visualization too. So just to give you an idea of the actual setup, I have a little video here. Over here is, can everyone see this?
Yep.
Okay, so here, I'm just going to move the video here. Over here is your Raspberry Pi, and then the output pins are just coming out to this this breadboard. So there's a couple of different sensors. This in particular is, these guys in particular, this guy and this guy, these shiny metallic things are distance proximity sensors. So they actually measure distance, distance from of an object that's in front over here. Then this guy with the blue light, that's the GPS. And back here, some guy, if I can see, yeah, that thing with the green light, that's a accelerometer and a gyroscope in there too. So I think if you wanted to sort of picture the best use case for this would be something like some sort of a vehicle. So if you imagine that you have a vehicle like this, right? And then obviously you have detection at the front and the back. So you might have another car back here and then another car back here, and you want to know if there's any objects which are coming too close to you. Maybe you have some collision detection or avoidance algorithm and things like that. In addition, you just want to log that data too. So I'm just going to show you a quick demo. Okay, so here is the Spark. Yep, here's the Spark submit. I'm just going to get that running first. Here's my MySQL database, which is right now it's empty. I got nothing here. Over here is my Raspberry Pi, which I'm going to start over here by sending data. So it's sending data packets here. If we come back over here, you'll see that this Raspberry Pi is actually sending sensor data from its sensors through a UDP stream to NIFI. NIFI will see over here, it's listening for UDP packets here. And then this is pretty much the standard. And you'll see that the packets are increasing here, and they're all going into the successful log attribute here. So it's getting that. Here's MySQL. So far there's 49 records. As you see down here, there's probably about 2 packets per second that are being sent. Over here is, I did make a little consumer, Kafka consumer in Python here, which is this over here. So it's just going to let us know what is the front distance and what is the rear distance. So over here, if you get if the car comes a little bit too close to here, you'll see that the front distance has decreased from 13 to 4. So this is actually just in centimeters. If the back one came a little bit too close to, then you can see that it's in real time that it's decreased to 4 also. So I can come out again, and then you're going to see these distances increase. So this is basically this Python monitoring is basically, as you see here, just another consumer, Kafka consumer. At the same time, while we're speaking, Spark Streaming is consuming the data also from the same topic and then outputting that to Parquet with Hudi metadata. Okay, so actually you'll see that the data here, it actually has things like the gyroscope data with acceleration and rotational things, and also GPS with latitude and longitude, but I'm not really using them at this time. That would be sort of more for a more real, something out in the real world. Okay, so I'm just going to stop this. I'll just stop the data here. And same with the Spark streaming here. Just stop that. Now here, so now we've got the Parquet data here. Now I wasn't able to automate this yet, so it's not automatically dumped into S3. So I'm just going to do that very quickly right now to just copy those files with the Docker copy command first, and then copy it to AWS bucket. So here we got 2 Parquet files, and in my bucket, oh, great. Okay, give me a second. Okay, so I have 2 buckets in here, and I'm just going to get glue. Oh, really? Okay, let me just open another one. And then I'm just going to get glue to crawl that data that's in the S3 bucket right now, right? And that's just going to take a minute or so. Yeah. So in terms of other sensors on this Raspberry Pi, I would have liked to use the gyroscope and accelerometer. I was actually aiming to sort of do a real-time visualization of the data that was coming in, which you can calculate from the accelerometer and the gyroscope. You can sort of visualize the pitch and the angles and the roll, all of those things that you would imagine for, say, an aircraft or a drone. But that required some additional calculations, which I didn't have enough time to get into. So we'll see that the crawler here is stopping. So we'll see the table here, which is vehicle monitoring. So it got that. I'm just going to change this here. The timestamp, this is some sort of weakness within from the glue crawler. The timestamp should be changed to a date time. Just going to do that here. And then we can see that in, just going to check that in Athena. And yeah, and there we go. So we can see actually the Hudi data is in here too. the Hudi metadata is in that Parquet file too. And we have our timestamp, and we're primarily going to be looking at the distance front and the distance rear. So we'll just like very quickly see this in, oh, oops. Let me just delete this one because I need to get the new data set. So we're just getting the data from Athena, vehicle monitoring here. We'll add that. And then we'll just visualize it very simply by looking at a line chart. So he's picked up timestamp automatically. We do it the granularity by second, and then we'll just see the distance front. And we'll also see the distance at the rear and see how that varies over time. Okay, so there you go. Oh, that's a little bit strange. Oh, okay. Well, that was a little bit of a bust, but it didn't. I believe that the Parquet, the data didn't pick up straight away with everything. So here you do see that the distance decreased over here. Yeah, this happens occasionally. I think it's some sort of a lag with the data monitoring. But well, over here, this is what we saw in real time. So basically it was, yeah. So we saw 13 centimeters going down to 4, then back up to 16 here. So all these happened, but I believe it probably, yeah, up here, this blue line is probably where it is 16. Yeah, and then it dropped somewhere. But yeah, actually, apologize for that. Actually, not everything was picked up perfectly. Maybe I was moving things around a little bit too fast, and maybe there was a bit of latency here and there. But this usually works. So yeah, that's about the end of my presentation. And if anyone has any questions, I'm open to it.
That's really awesome work, Albert. Just a quick question. I remember you were, trying to do the NIFI within Raspberry Pi to getting the sensor data. Did you end up doing that, or just, directly, kind of sending the sensor information to the NIFI's endpoints? Like, what's the?
Yeah. Actually, I actually tried for a few days on
Yeah.
the NIFI.
Yeah.
And I just couldn't get it working. Yeah, I just had a really hard time, and so I ultimately reverted back to just a simple UDP stream. But yeah, the NIFI tutorials I found everywhere, and the documentation, it seemed like most of them were like 5 years old, or even 6 years old. So it didn't seem like it was that there was not a lot of information online on it, and I just couldn't get them to communicate.
Yeah, I mean, so basically, you're just using like a UDP, kind of sending directly to NIFI's like UDP endpoints, and that data is being kind of communicating back and forth between.
Yep.
And just using your homes. I guess when you were doing the videos in terms of all the car objects moving back and forth, that was in real time.
Yeah, exactly.
Okay, that's okay.
Yeah.
I was thinking you were recording something. Okay, so that's a real time sharing the moving.
Yeah, exactly. So yeah, you sort of saw me moving the cars back and forth, and then and basically this just showing the distances here. This is all in real time, so it's actually nice to see that with not too much latency, and I'm sure you can optimize it for true real time.
Yeah.
That you can actually see these different cars coming in and out. So that so it's sort of perfect for some sort of a real-time application of like a remote control vehicle, like a drone, or even like like a Mars rover or something like that.
Nice. By the way, where did you get in the additional accessories for the Raspberry Pi, like all the sensors and everything? Do you get it from Amazon or?
Yeah, Amazon has everything, but it's really cheap if you actually get it from AliExpress, direct from China.
I see. Yeah.
But it takes 3 weeks. But yeah, like a tiny sensor like this, it's just like $2 or $3. Even the GPS module is only I think 5, something like that. Yeah, so you can play around really cheaply. Yeah.
Nice. I'm in the process of teaching my son, in terms of how to play with Raspberry Pi. But I guess, what you've done is something I'm going to add in my to-do list, to show all the sensors and everything. So yeah, thanks a lot. That's really amazing work.
Okay, thank you.
Thank you, Albert.
Albert.
Yeah.
Are those your toy cars or
no,
belong to your kid or?
No, they're my daughters actually. She's taken a liking to cars and planes now. So
Nice.
it's very perfect that I had this little car and that it happened to like fit this breadboard like perfectly too. Yeah.
Car is amazing as well. I was wondering. Nice.
Yeah. And I actually have this is actually over here, it's actually a camera module. I mean, if I was really ambitious, like Justin, I would have actually tried to do the video, like some sort of live video streaming, but I knew I couldn't do it, given the time frame.
Yeah, I mean, that's close to a startup's kind of vision, getting a camera, getting the, front and rear vehicles, license plate and do something about it. That would be, super cool. But,
Oh, yeah.
Maybe you and Justin can think about opening up a startup, based on this whole thing.
Okay, I'm going to stop sharing. And thank you very much.
Thank you, Albert. That was really cool and awesome.